Welcome back, everyone, for section 1. Oh, wrong marker again. Wanted the highlighter for section 1.3. And in the section, we're going to take a look at how sample data is collected, right? The key concepts or the major ideas for this section are going to be the idea of the methods that are used to collect data and how that can influence the quality. We're going to take a look at the idea of the OG, if you will, of gathering data, and that's a simple random sample. And then we're going to talk about how, depending how you collect your data, if it's not collected in an appropriate way, how it could basically be useless. That no amount of stats that we can do, no amount of number crunching we could do, could ever make it worthwhile. Okay. All right. So the basics of collecting data, right? We basically, if broad strokes here, we basically obtain data from two distinct sources, or in two distinct ways, if you like to think about it that way, through things called observational studies and from experiments. And those are the two broad strokes, the ways we gather data. An experiment, by definition, is where you apply a treatment and then you observe its effects. Okay? So you've got something that you think, so you have graduated from college and you now work at let's say the Eli Lilly or some drug manufacturer, and you think that you have created a new pain medication that will reduce pain in more people and it's not addictive or whatever, right? So you're going to gather data to determine whether or not it actually works. That data you're going to gather is through an experiment. So you're going to apply a treatment, and that treatment would be to, in this case, give the new drug to some people. And then you would observe its effects. So you'd measure somehow objectively the pain levels. So their pain level before, their pain level after they take the drug kind of thing. And you'd then use that data to determine whether or not this new drug of yours works really well or works okay or doesn't work at all. Right? But the idea of this word right here, this idea of this word treatment, right, that's some treatment. That's whatever it is. That's the poking with the stick that you do to see what poking with a stick does, right? And what it does is when you observe its effects. So you're actually reaching out and touching each experimental unit. The experimental units are the things in the unit or the individuals, or if they're people, we sometimes call them subjects, but the members of the sample group. Right? Contrast that with an observational study. Now, in an observational study, there is no poking with a stick. All you do is you observe and measure whatever it is you care about, and you do nothing to modify the reality of the situation. So you're not giving a drug and then measuring the outcome. You're not poking with a stick. You're not doing anything. So if I went back to my cans of Coca-Cola that are supposed to have 12 ounces in them, if I go down to the production floor and grab some of those cans and I measure how much is in there, I'm doing an observational study. Because I didn't in any way influence how much soda is in the can. I'm just saying, hey, how much is in there? I'm observing and measuring that characteristic that I care about, which is how much soda is in that can. Okay. For example, if we take a look at the idea of a relationship between these two things, is there some sort of a relationship between ice cream consumption and drowning? Well, if you were going to do an observational study on it, you would gather some data about ice cream sales and drownings. And you might make a conclusion that there is an increase in ice cream sales associated with an increase in drowning. That when ice cream sales go up, drownings also go up. And you might think that, oh, there is some sort of correlative relationship here. That if we were to, say, graph it, and down here was ice cream, and over here was drownings, that you might think that there's some sort of relationship that as one goes up, the other also goes up. And that could be true. There could be a relationship between them. Doesn't mean it's causative, but it could be correlative. Contrast that if you were going to do an experiment to see if there was a relationship between ice cream and drownings. Well, if you were going to do an experiment to compare the two, you would take one group and you would treat them with ice cream. And there's a play on words there because ice cream is a treat, but it would be the treatment. So you would have one group eat ice cream while a second group would get no ice cream, often referred to as the control group. And then you would measure the rates of drowning for the victims, drowning victims for both groups. And you would say, okay, is it the same for both groups? Is it different from one group to the other group? And if you actually did that, you would see that the ice cream consumption has no effect on drownings. Right. So an observational study, I watch, I listen, I measure, I don't apply a treatment. An experiment, I apply a treatment, and then I measure. Right. All right, design requirements for experiments. If you're going to set up an experiment, here are some requirements. One, it has to be replication. Right? Replication is the repetition of the experiment on more than one individual. So you can't just give the treatment to one person, measure their results and go, yep, it works, or nope, it doesn't work. It has to be more than one individual. So you must repeat the experiment in the exact same way on more than one people. Right? Good replication requires sample sizes that are large enough so we can see the effect of the treatment. Now, I know what you're thinking. What's that mean? Large enough. How large is large enough? Well, when we get later into the book, when we get later into the semester, we'll actually come up with ways to measure that. For right now, 30 plus, 50 plus, something like that, a large enough group where we can say, yeah, there's some statistical validity to this. Right? Obviously, the larger the group, the more we can argue for the outcomes are. We can use the outcomes to predict things, but at the same time, larger groups cost more. They cost more money, they cost more time, they cost more of everything. So there's a balance that has to be found. Okay. Also, in an experiment, we often worry about this blinding. Okay. Blinding is a technique in which the subject doesn't know whether they're receiving a treatment or a placebo. Now, I'm tossing that word in there, placebo. I'm assuming you guys know what that means. That's a fake pill. So everybody gets a pill, and only some people have the actual drug, and some people are just getting a sugar pill, the placebo. Okay? Blinding is a way to get around something called the placebo effect. Okay? The placebo effect is when an untreated subject reports improvements in symptoms because they think they got the drug. And if you think you got the drug, you might in some way affect the outcome of the experiment. That would be referred to as the placebo effect. But if everybody's taking a pill and you tell everybody everybody's taking a pill and you don't know whether it's the real one or not, it tends to reduce the placebo effect. Doesn't remove it, but reduces it. Okay? Double blinding is a step more than blinding. Double blinding occurs on two levels. It's where the subject doesn't know and the experimenter doesn't know. Now, there's a reason for this. Let's go back to that one about that new pain drug. Right? Suppose that I'm the experimenter and I develop this drug. And if I can prove that this drug works, or if I can show results that make me believe this drug works, I stand to get rich because I'm going to sell the patent for this thing and I am going to make money. Well, if I have a financial interest in the outcome of this study, I might unconsciously, because I'm a good person, I may unconsciously affect the outcome if I know which people are getting the drug and which people are getting the placebo. So if we double blind this, where they don't know and I don't know, I am much more likely to not unintentionally or intentionally, if I was a dishonest person, affect the outcomes of this study. So the idea of the experimenter not knowing whether or not this person has the real drug or not. So then when I ask them, hey, does your pain go down? I might be more open to an honest interpretation of their answer, not some sort of unconscious bias that I might throw into there. Right? So there's blinding and there's double blinding. Blinding is when the subject doesn't know. Double blinding is when the subject and the experimenter. Right? Last thing we want to take a look at is the idea of randomization. Randomization is the process in which subjects are assigned to the different groups. We want to make sure that it's random. Right? If I end up with one group that's all people who identify as male and another group is all people who identify as female, that's not random. That couldn't have happened by random. Or if one group is all people who live in the suburbs and one group is all people who live in the city, that's not random either. Right? And by not being random, I might impart some sort of bias, some sort of like non-truth to the study or to the experiment. And I don't want to do that. Right? So these are the things that a good experiment will have in it. And if you were reading a journal, say, article about something, and they were telling you how they designed their experiment, you would look for these things to be done, whether it's blind or double blind. How many people did they do it to? Was the sample size large enough? If you're reading something and they're talking about a sample size of 5 people or 8 people, and they're trying to say that, hey, our results are going to be useful to talk about the entire population of everybody, you might look at that and go, really? 5 people? That's enough? Because I don't think it is. You want a larger group. Right? When it comes to sampling, when it comes to getting the people or the individuals to put into our study, into our experiment, how do we do that? From where do we gather our data? What techniques or what processes should we use to select our sample? Well, the easiest, the OG, the king of all, is the simple random sample, an SRS. You'll often see it abbreviated as an SRS. A simple random sample says that a sample of n subjects, so whatever n is, so a sample of 20 subjects, or a sample of 50 subjects, or a sample of 30 subjects, and it just represents how many, is selected in such a way that every possible sample of that same size has the same chance of being chosen. Right? Okay. What does that mean? Well, you would choose your sample in a way that if you repeated the process, a different group of the same number of people would have the same chance of being chosen. Right? So you wouldn't pick the first 10 people that signed up because there might be a bias there. Why did they sign up first? You wouldn't pick the last 10 people to show up. You might randomly sample from the group, maybe a random number generator to pick people or something like that. Assign every person a number, use a random number generator to pick 50 numbers. There's your 50 people. Right? There's something called systematic sampling, which we sometimes use. Systematic sampling is selecting at some starting point and then selecting the kth element in the population after that. Right? A good way to think about this would be go back to my Coca-Cola can example. Suppose that I need 50 cans for my sample. I could go down to the production floor and be at the end of the assembly line where the cans are coming out already filled, already closed, already ready to go. And I could start at some point, just pick a random can, and then every 5th can after that, or every 12th can after that, just pick some random number and then start with the first can, whatever one I pick, and then 1, 2, 3, 4, 5, grab that one. 1, 2, 3, 4, 5, grab that one. 1, 2, 3, 4, 5, grab that one, until I reach my 50 cans for my population. Systematic sampling. Right? It's really common when you have production line type stuff to use systematic sampling. Right? There is something called convenience sampling. Now, convenience sampling is just when you use data that's easy to get. It's convenient. Right? This is, well, let's put it bluntly, this is bad, right? This is, why is it easy to get? And if it's easy to get, is it accurate? If it's easy to get, does it truly represent the population that you want to get your data to represent, right? A great thing to think about is convenience sampling, and I think we've all probably experienced this. Have you ever been at the mall and there's that person standing there, and in their hand they've got that clipboard, and you know that they're doing some sort of survey? And so as you walk by, you turn your head the other way, or you pretend you're on your phone, or you mean mug them so they won't talk to you. Who do they talk to? Well, they talk to people that are easy to get data from. That would definitely be convenience sampling. Usually a bad thing. Rarely is convenience sampling ever a good thing. Okay? If I wanted to gather information, data about Glendale students, and I only talk to the students who are on campus on Tuesday mornings when I get there, that's convenience sampling. It would be easy for me because I'm there at Tuesday mornings, but if I'm only talking to students who are there on Tuesday mornings, I'm not talking to Monday students, I'm not talking to Wednesday students, I'm not talking to Thursday students, I'm not talking to afternoon students, I'm not talking to evening students. So my data wouldn't generalize out to anything other than, at best, Tuesday morning students. And that's not good. Right? Stratified sampling is a technique where you stratify or you subdivide the population into at least two different subgroups that have the same characteristics. Right? So I might take my entire population and I might stratify it by saying, break it up into, say, 4 groups where all share the same characteristics. So everybody over here has at least 1 year of college, 1+ year college. That's a characteristic. And I put everybody into all 4 groups that all have at least a year of college. And then I get a sample from here. I get a sample from here. I get a sample from here. And I get a sample from here. Now, why would I need 4 samples from 4 different groups? I don't know. That just might be how I want to gather my data. Or maybe I'll stratify it a different way. Maybe I'll take my data and I'll stratify it by income. And these are the people who make up to 50 grand a year. And these are the people who make up to 100,000 a year. And these are the people who make up to 150,000 a year. And so on and so forth. And then I'll pick some from this group, and I'll pick some from this group, because all these people have 50K. And I'll pick some from this group, and I'll pick some from this group. Right? Stratified sampling just says subdivide the population into groups that have the same characteristic. Right? Cluster sampling. Cluster sampling is a technique, and it's usually used if you want to divide the population into areas and then randomly select in those clusters. Okay? So let's say that you were going to survey people who live in Phoenix, and you wanted to get information about how they felt about a new bill that was being introduced to pass through the Arizona State Senate. And so you would break your area down into clusters. And so this would be like neighborhood 1, this would be neighborhood 2, this would be neighborhood 3, this would be neighborhood 4. And then you would randomly pick a number 1 through 4. And let's say we randomly pick 2. You would go into neighborhood 2, knock on every door in neighborhood 2, choose all the members of that cluster, and ask them their thoughts on it. Right? Now, realistically, 4 is too small. You could break it down, divide that population area into 50 sectors and select 10 of them. And then go into those 10 and knock on every door there. Right? Cluster sampling is really common when they're doing door-to-door surveys. That's exactly what it was designed for, is that idea of going door to door and knocking and saying, hey, how do you feel about this? How do you feel about that? Okay. Multi-stage sampling is where you take all of the things above and kind of mix and match and use them however you want. You collect data using combinations of basic sampling methods. That's multi-stage data. All right. Suppose that you've set up your experiment, you've figured out how you're going to get your sample, so you've got your sample determined. How do you get your data then? Right. Well, if what you're doing is an observational study, there are basically three broad categories. One is a retrospective or case control study, where what you do is you go gather data from the past and you collect data out of that. So suppose that I wanted to, what did I do there? Oh, suppose that I wanted to get information. I'm doing a study on where people emigrated from when they came to the United States. I might go to Ellis Island, look at old records of where people emigrated from, and collect my data there. I also might go over to, say, San Francisco. That was another big port of entry, and gather data from there. Okay. Now, when I say go to Ellis Island or go to San Francisco, I would go online because all that data is online. But it would be the idea of getting data from the past, pulling information out of there. Okay. You can also do something called a cross-sectional study. Okay. Cross-sectional study is when you measure data at one single point in time, not over a period of time, not going necessarily into the past or into the future, but pick one point in time. Right? So it's not longitudinal. It isn't over a period of time. It's at one point in time. Right? So if I wanted to do a cross-sectional observational study on what color backpacks students carry at Glendale Community College, I could go out and stand in the middle of the quad, and as students walk past me, I would observe what color backpack they had. Right? So be careful with this, because sometimes people read that and go, it has to happen exactly 10:02 a.m. and that's it. That's not really what that over a period of time means. If I stood out in the middle of the quad and collected data for 30 minutes on what color backpacks people had, that's not a period of time. I mean, technically it's a period of time. I get it. That's not what this means. This period of time would be, I did it this spring, I did it last spring, I did it the spring before, I'll do it again next spring. That's what that would mean, over a significant period of time. Okay? When you gather data over a significant period of time, that's called a perspective or longitudinal or cohort study, where you collect data and you then collect more data and then you collect more data into the future. Okay? All right. The key thing to remember about observational studies, though, is they only observe and measure. They do not modify reality. Okay? Contrast that with how would you extract the data if you were doing an experiment? Well, if you're doing an experiment and you're poking people with a stick or giving them a pill or whatever it is, you literally run the experiment. You have your experimental group. That's the people who get poked with the stick. You have your control group. That's the one that doesn't. And then the time really doesn't matter in the sense of I'm doing the experiment based on however long it takes to run the experiment. So if my experimental group is using some sort of a long-term pain management drug, then my experiment might need some time. It might need a month or 2 months or whatever for the drug. Or if it was, they just released that weight loss that was been a shot. They just released it as a pill. And I'm sure when they were doing the study on that, the experimental group didn't get the drug once. They got the drug several points in time. And so there's the idea of the time definition here is less relevant because the time is defined within the experiment. All right. Again, remember, chapter 1, you're not supposed to walk away from this with some great, deep understanding of statistics. The big idea here is there's going to be terminology that's going to be tossed at you. And hopefully when you see some of this terminology, you can parse out what it means and feel comfortable with what it means. Okay? All right, that brings us to the end of chapter 1. Isn't that wonderful? We're already one chapter down. All right, you guys have a great day.